Okay, last video for trig. Just a reminder up at the top of your page. SOHCAHTOA, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. All right, we're going to use the same principles that we did the last 2 days, except now we're going to introduce some word problems over angles of elevation and depression. Angle of elevation is going to be based off of your eye level looking up. And angle of depression is going to be based on your eye level looking down. So notice that both of them start at that horizontal and work their way either up or down. The reason that we have these in our boat down here, if we are looking up, this is our angle of elevation. And if we have a buddy who's at the top of our lighthouse looking straight out and then down to us, what you'll notice is that if these two horizons are parallel, then these two angles of elevation and depression are always going to be congruent. We just have to make sure that we get them in the right place in our diagram. Okay, so we've got our pilot with a rescue plane and a life raft. I'm going to go ahead and draw out my right triangle. Please draw these triangles. I promise it will be to your benefit in helping you set things up. So here is my plane, here is my raft, and it tells me that the plane's altitude is 3 kilometers and that our angle of depression is 28 degrees. Remember that that is always from the horizon. So option number 1, if my plane is here at the top, then my angle of depression is here, which I can also put as my angle of elevation from the raft. Those are the only 2 places that we can put that. A common mistake is to put that here, but don't do it. Always start from the horizon, working your way either down or up. So now that we've got our 28 degrees in place, what is the plane's distance from the raft? I get a lot of questions of, is this the horizontal distance? Is this the hypotenuse? My tip to you is to put a finger on each and start there. So if I put a finger on the plane up here and one on the raft down here, and I connect the two, that's the piece that I'm looking for. And now we just set up our trig ratio, kind of omitting the whole word problem. So I've got my 28 degree angle down here at the bottom. So I've got my opposite and my hypotenuse, which is our sine ratio. So the sine of my 28 degree angle is the opposite 3 over the hypotenuse. And to get that calculator ready, I'm going to have 3 divided by the sine of 28. Just a reminder again, please make sure that you are in degree mode. So 3 divided by the sine of 28 is 6 points, says round to the nearest hundredth, 39. Make sure that you put in your units, kilometers. Another way that you can do this once you get that 28 worked in there is if you have, if you want to, you can use this complement to the 28 to solve your problem as well. I would say just use the 28 and put it either down here at the bottom or leave it there and build your triangle the other direction, but I really wouldn't suggest that, but it is an option. All right, next piece here says a kite is flying at an angle of elevation of about 40 degrees. All 300 feet of the string has been let out, ignoring any slack in the string, and approximating that the person holding the string is at a height of 4 feet above the ground. Find the height of the kite. So here is my kite here, and my string is 300 feet. Here's my right triangle. The only thing here is that now we've got this person standing here, at a height of 4 feet is where he's starting to hold the string. So whatever we get for our height over here, we're going to have to add that 4 feet to it. So it tells us that our angle of elevation is 40 degrees. I'm going to place that here. And now we're just going to solve for x and then make sure to add that 4 feet to the bottom. So in reference to the 40, I have the opposite and the hypotenuse. So I'm going to use sine. Sine of my 40-degree angle is equal to the opposite, x, over the hypotenuse, 300. So to get that calculator ready, I'm going to do 300 times the sine of 40. So that is 192.8. Let's see. What does it tell me that I need for my, let's see, approximating, let's just say to the nearest foot because it doesn't really tell us anything. So let's say that's 193. And then be sure and add the 4 to it. So 197 feet would be the height of our kite. A road has a grade of 10%. This 10% is out of 100. So for every 10 feet of vertical distance, we have gone 100 feet of horizontal distance. That's our setup for our triangle. I don't know that you'll encounter any grade questions, but if you've ever been skiing or been in a hilly area, you'll see these. So our 10% is representing not the angle, but it's representing our height over our distance run. And then we're solving for our angle. So in this case, we'll use our trig inverse. I have the opposite and the adjacent. So I'm going to use the tangent of x is equal to the opposite 10 over the adjacent 100. And to get that calculator ready, I'm going to do the tangent inverse of that ratio, 10 over 100. So let's see, tangent inverse, 10 over 100. And let's just go ahead and round it to the nearest degree, so 6 degrees. And last one, we're kind of splitting this one problem up into 3 pieces so that we can solve it. We essentially want to know how far apart person B and person C are from each other. It tells us that our hot air balloon is 600 feet up. So what we're going to do is we're going to find the distance from underneath down to person B. We're going to find the distance straight down to person C and then subtract the two to find that difference. So our angle of depression from the line of sight to person B is 30. Remember that that is from the horizontal down, so I'm going to put that 30 degrees here. And I'm going to go ahead and just draw this out separately. I've got my 600 and 30 degrees, and I need this down here, so I'm going to use tangent. Tangent of my 30-degree angle is equal to the opposite 600 over the adjacent x. So calculator ready, I'm going to do 600 divided by the tangent of 30. And that is, we'll just round it to the nearest, let's see, nearest foot, 1,039 feet to person B. And then let's check to person C. What we are changing now is our angle of elevation or depression, however you want to look at it, is now 20 degrees. And we are solving for that same distance. So the tangent of 20 is going to be equal to 600 over x. And same thing, my calculator ready is 600 divided by the tangent of 20. So I'm just going to go back here, back that out, and do 20. and it is 1648. And now we're going to just subtract those two. 1648 minus 1039 is 609 feet. Please be very careful with how you set these up. Remember that your angle of elevation and depression can be used as the same measure. Just make sure that you're choosing the right place to put it. Always go from the horizontal up or the horizontal down, and you will be in good shape as far as setting up the problems. Once you get those set up, it's as easy as working them through the way that we did in the last couple of days.